Deep in the Canadian Arctic lies Devon Island. It is the largest uninhabited island on Earth, a freezing, jagged expanse of red-tinged rock classified as a polar desert, which is a high-latitude region that receives almost zero precipitation. This isolated stretch of ice and stone attracts two very different groups: the world's most specialized astrophysicists and an intense, viral community of internet conspiracy theorists. Many online theorists claim that space agencies never actually went to Mars. They post side-by-side photos of Martian landscapes and Devon Island, arguing that the pixel-for-pixel similarities prove modern rover images are faked right here on Earth. These theories are fueled by the island's history of unexplained events. In the 1930s, fur trappers reported strange blue lights soaring over the tundra. Around the same time, at the nearby Lake Anguni, an entire Inuit village of 27 people seemingly vanished overnight, leaving behind their kayaks, their hunting rifles, and half-eaten food. The island's lethal nature is a direct consequence of an ancient, violent geological collision. Millions of years ago, Devon Island was a temperate ecosystem, covered in dense vegetation and complex wildlife. 39 million years ago, a 2-kilometer meteorite slammed into the surface, carving out the Houghton crater. The strike shattered the bedrock, creating a climate where winter temperatures hit -50 degrees Celsius, and the growing season lasts only 40 days. Starved of warmth and sunlight, the vegetation died off. The meteorite impact locked the island into a state of permanent polar desert, creating a jagged, barren environment that rejects human settlement. In 1845, Sir John Franklin led a massive 129-man expedition to map the surrounding sea routes. Before they could finish, their 2 heavy wooden ships became hopelessly trapped in the freezing sea ice surrounding the island. The crew faced a slow, desperate decline. They succumbed to starvation, extreme cold, and lead poisoning from their food rations, leaving behind scattered debris and a few frozen graves near the shoreline. In the 1930s, the Canadian government aggressively attempted to assert territorial sovereignty over the Arctic by establishing Dundas Harbor Outpost. They forcibly commanded 52 Inuit families to relocate to this remote police outpost to create a permanent, forced human presence. The settlement failed rapidly. The brutal winds and frozen soil made traditional survival nearly impossible. Within a few years, the surviving families fled, leaving behind collapsing wooden structures and an unmarked cemetery for those who couldn't escape the cold. Centuries of frozen shipwrecks, completely missing villages, and long abandoned outposts definitively prove that Devon Island's lethal isolation makes survival impossible. For NASA, that hostility is a vital resource. In 1997, scientists established the Houghton Mars Project. They use the island as an analog site, a location on Earth that shares physical and environmental characteristics with a location in deep space. The island's barren, rocky terrain, its hyper-arid freezing winds, and its lack of solar energy mirror the conditions on the surface of Mars. Aerospace engineers bring their next-generation prototypes here to test their endurance. They force autonomous rovers to navigate the jagged terrain and test heavy, pressurized spacesuits against the sharp, abrasive dust of the crater. Human crews also endure weeks of isolation inside cramped habitats, operating under the same communication delays and stress levels that astronauts will face during a mission. Subjecting equipment and human minds to this environment allows engineers to identify and fix fatal flaws while they are still close to home, rather than discovering them millions of miles away in space. Beyond engineering, the island serves as a training ground for paleontology and the search for ancient life. In 2007, researchers unearthing sediment from the crater floor found the remains of Puigila darwini, an extinct, semi-aquatic mammal recognized as an early ancestor of the modern seal. Extracting these delicate fossils requires chipping through permafrost, a thick, subsurface layer of soil that remains permanently frozen year-round. This excavation gives scientists the procedural experience they need to hunt for ancient microbial life trapped in the frozen craters of Mars. This frozen graveyard serves as a mirror for the Martian surface, a testing ground where we can refine our equipment and our search methods before we reach the next planet.